Hello everybody, welcome to this 12th stream on OpenHT KiCad project. So today KiCad is already open, and as you can see, or maybe as you have seen, some changes have been made on the board since the last stream. So I did some off-stream work, mainly because it was boring stuff, and I also kind of needed to focus on it. So I wanted to be able to do that calmly off stream. So mainly I think one of the main things is that the transceiver have moved a bit on the left, so that we have room here to place the shield, and it's more aligned with the FPGA for the differential pairs of the LVDS transmission lines. So I picked a second shield design, which is this one, which is a bit smaller than the one we placed on top of the power supply. And conveniently, we should be able to reuse it without too much trouble for the transceiver. So this one is placed. You can also see that I made some openings on the shield on the top left and on the bottom. So on the top left, because I had some signals that I had to take out of the shield, and of course on the bottom for the LVDS pairs. I really don't want to have any vias in those pairs, because it is gonna impact the impedance of the line, and it might make it difficult to go at the required frequency. So like this, it should be perfect. But maybe you have seen too that this shield, it's not finished yet. So we have lines crossing, traces crossing the shields, which is not feasible, and even for the LVDS pairs. So what we are gonna have to do today is finish routing some signals, and then we are gonna need to create the required openings in the shield to take the tracks out of this area. And yeah, that's the plan for today. Placing the shield, and if I remember correctly what I said, then we should be able to start doing the cosmetic changes. Mainly update the silkscreen, which you can see is a mess. There is nothing. Yeah, it's not good. We have to move all the. We will resize all the text so that they are smaller and can fit in tighter spaces, and also rearrange them so that it's at better locations. Okay, so at least that's what we are gonna try to do today. We will see how it goes. Oh yeah, one more thing that we need to do is place a TVS diode right here on the SMA connector, and yeah, we are gonna need to pick and also the battery connector. For now, I chose this one, which was kind of a generic one, but we should be able to decide on one now. But maybe we will discuss that in the chat, so depending on how you feel about it. So bonjour Pierre, hello Foycher. Glad to see you today. So yeah, let's get started. So I moved a bit the RF part of the design, and I'm not really pleased yet with the current layouts, because as you can see, I don't have enough room here for the two switch control capacitors and so on. So I need to update that. Then, but yeah, I think we are gonna need to create an opening, at least for the RF output, input-output track to the connector. This will need to be, you will need to create an opening for that. This, I think for these tracks, we should be able to make them go to the bottom layer and route them to the connector. These I don't know yet how I'm gonna do, because if you remember, this is where the speaker is gonna be placed. It's gonna be placed on the bottom part of the on the bottom of the board, sorry. And yeah, I really wanted to avoid having tracks going on the bottom layer under the speaker, because I fear that the speaker might induce some noise in it, and yeah, that would be no good. Okay, let's start by the RF part. So maybe we can start already. Yeah, okay, I'm gonna break the track here and here so that I'm able to keep routing this signal. Otherwise KiCad won't let me. Okay. So maybe yeah. I'm maybe gonna try to place that a bit high. Yeah, but not by too much either. So yeah, and for the RF signals, I'm gonna do rounded tracks. Yeah, like this. This is too close, I don't like that. So maybe I can try to move that here, and this needs to go yeah, this is getting tight, a bit too much to my taste. One of the possibilities would be to audio. Okay, audio should be back to normal level. Yeah, so as I was saying, this is getting too tight for my taste. It's getting hard to route the RF signal without having I fear that if we do a layout that is too tight, we might have integrity issues on the signal. I'm not really sure. So one of the possibilities would be to keep going until we find a way to make it fit. Otherwise, we could also try to upgrade the shield, but I would like to keep either using
this shield or this one. But as you will see, this one is maybe a bit too big. Which is, yeah, too big is not an issue, but I would like to avoid that. Anyway, so let's keep trying until we find a way to route everything. Okay, let's see if this yeah, not the best routing. But because of this capacitor, it's hard to do anything else. So oh wow, this isn't good. Okay. Okay, so yeah, it's a bit of trial and error trying to place things until we have something that we can, let's say, agree on. I'm gonna remove that. And this should be placed like here, would be nice. Yeah, not really. That's one of the annoying things with the rounded tracks, is that they can't be dragged like other tracks, or at least I didn't find a way to drag them correctly. Okay, this is better. So, like this. Except that I don't want this huge rack here. Okay, it's way too large for this small pad, so let's pick a smaller one. Okay, like this. And it's still not good. Okay, now it's good. Come on. Okay. So the power supply, it's good. Yeah, but I would like maybe to try. Okay, could we place this one? Yeah, this way. Then we can try. Okay, like this, and try to move that up so that this one is aligned with this. Okay, this way we can have the room below to route the tracks for the switch control. Okay. Hey Andy, doing fine, and you? I think the audio messed up again. Okay, is it better like this? Yeah, doing fine, and you? How are you? No, this is okay, and can we place a via? Barely. Ooh. Great. Okay, so this also. Okay, and so this capacitor needs to go here. Oh no, it needs to go higher. But then, if I make it too high, I guess it will not fill the ground here. Would it be okay? So, okay, let's raise that a bit more. And actually, let's switch to this way of routing. Can I still fit via? Yes, I can. Except that this is too wide. As I said, some tasks can be quite boring. Okay, here we go. Okay, so removing old tracks. I will need to keep few vias around here, and so I can bring that one to here, I guess. A bit too much. But now I have plenty of room to place this via right here and route the switch control signal just as yeah, okay, like it's perfect. This gap needs to go here. Well, let's, okay, like this. Okay, perfect. Which grid do I have? Oh, the thinnest, the smallest one. Okay. Okay. Great. I would prefer to have a sliver of ground in between the via and the shield, just in case. Okay, what's this mess that we have here? Seems to be good now. Why is this? Okay, this now aligned. Okay, great. And this needs to go here. Let's try to keep it perpendicular. Okay, that's not bad, actually. Maybe I can pull that back a bit. And I have the room for via. Not quite. Yeah, no, I do. Okay, perfect. Okay. Let's place vias all around the RF tracks. Hi Steve, yes, time to tune in. I started the stream early so that people could put their clock and remind to come to the stream, and you forgot. I'm a bit sad, I have to say. Okay, ground via here, ground vias everywhere. So the role of these vias is to act as a kind of a shield, a barrier to have a good ground and avoid having any signal kind of leaking. Oh, you were at lunch. Hope it was tasty. Is it good? Oh, yeah, okay. It's barely. Okay, that's very tight. Should we have like one here and one here? Be good, okay. Yeah, kind of a curtain indeed. Okay. It's just that now I have this huge one in the middle and I don't know how I can hide it. Except maybe do this. Yeah, okay. It's kind of weird routing without the footprints, but anyway. Via curtain, some software call it via shielding. And when it's between planes, it's via stitching. Yeah, let's be glad that they have machines to do that. Yeah, because it would be madness trying to drill all these. These are centered vias, so it's a drill bit that does them. It's not yet micro vias. It's more expensive. But then the micro vias, they are done via laser. So the thing is that when you do a large batch of boards, then you can, if you have like the starting price for the micro vias with the laser, it's more expensive because it's more expensive machinery. But in the end, per via, it's cheaper to do the micro via thing. So sometimes they will just use micro vias because in the end it's cheaper anyway, even though the starting price is. So the fixed cost is higher, but the variable cost is lower. So at some point you have a break-even point, and you use micro vias, I guess. Well, you can't use micro via everywhere either. Okay, let's try not overlapping them. I don't think it would be problematic if we overlapped them, but I don't know what the minimum hole-to-hole distance, and we still aren't decided fully on which manufacturer we are going to use, so. Okay, can I try to, yeah, I should be able to. Ah, okay. Okay, great. Oh, this poor ground pad isn't connected. There you go. Let's put a keep out under this component because I don't want the... Yeah, I want it to be as flat as possible below this without any area filling in the way. So let's just keep out copper filled, and it will be this name. Okay. Placing vias like crazy. I guess here we don't have the room for it. No, yeah. Let's keep it as is. Then I need to connect to the power supply, and this is very low power, so yeah, let's not bother too much and just connect that this way. This can move a bit like this. Okay. Some more vias right here. Let's place one here too. Okay, so now we need to do an opening for the RF track. And so for that we are gonna have to edit the footprint. So yeah, this, for example, is not the footprint in the library. It's just that I made the footprint in the library and then I edited it, and so it's just the footprint on this board, not in the library. So I can I have to edit the footprint. Yeah, open in footprint editor, and now I can duplicate this pad and let's start. So I think I should translate everything. Yeah, okay, because I need to do so because the pad does need to be in one piece. If I don't do that, it's gonna complain. However, what I can do is make several pads with the same pad number, and each one is its own piece. So that I can do. Okay, why is it not 90? So we are just gonna translate everything by yeah, like this. Okay, so now not quite aligned. Okay, here we go. And so how am I gonna do that? So I will need to create an opening on top, 1 and 2 on the bottom. So I'm actually gonna need one more, but okay, we are gonna do that as we go along. So the first one is gonna be the one, so we are gonna remove the right part of it. It's still not 90. Why? Why is this one not 90 and all the others are 90? It's annoying. This needs to go, this needs to go. This one needs to end more like this, and this one also okay, something like this. This one, we are gonna remove the leftmost parts of it. So this needs to go. This. This starts here, and this one also starts about here. Okay, so let's just save it and see how it goes. Okay, so this one needs to be maybe modified a bit. So yeah, that's what I was saying yesterday on the Discord about the wiggles. I don't have much room to place them, so I don't think I'm gonna keep them. Yeah, I like Québécois swearing. It's so... I find it funny. I don't know why. It's not to make fun of you guys, but it's so different from the French that we hear in Europe. Wiggles always in our heart. Don't worry about that. Maybe I could like add wiggles in a useless signal or something like that. Just kind of an inside joke. And any snitch trying to copy the design is gonna wonder why we have this wiggle, and then maybe they are gonna keep it. Who knows? So this also needs to okay, should I maybe I can try to, I don't know, okay, I'm gonna try modifying a bit this. So remove, delete, and delete that too, and maybe we can okay, this is yeah. Why don't you display something? Hey. Okay, this doesn't work. Why? Ah! Is it like this via in the way? Oh, yeah, it was. I think no. Insert lots of swearing here, yes. Yes, indeed. And I'm in stream, so I can't swear too much, but I promise you that yesterday I was getting annoyed sometimes. That's a few times I was like, yeah, it was really annoying. Okay, I'm gonna edit this primitive. Yeah, this one, so that it's ending. Let's try 5 mm. Oh, that was maybe too much. So let's add one more. Okay, okay, I'm satisfied with that. Except that this one needs to be modified a bit too, because we don't have a ground going all around, which I don't really like. So let's remove 0.5 mm, which is way enough. Okay, great. So vias, of course, vias, we need them everywhere. And then let's add some along the way. Do we have the room? No, not really. Let's make some room for the vias. Right here. Come on. Here. I'm gonna try to keep them kind of aligned after, but let's just place them, and then it will be in the cosmetic part of things, trying to to get it to look nice. I guess here it's okay. Okay, this will be edited too later on to be tighter, because yeah, this is just a large hole. Maybe we could. Oh yeah, maybe we should try to. Okay. So we are gonna make all the tracks go by around here. So we need to move them a bit to narrow it, but I'm gonna already modify this endpoint. Let's remove 5 millimeters, or yeah, maybe even one more. Hello Bastien, how are you? So we want to have a neck around where it goes through the shield, but not before and not after, because it will allow us to place vias right here, for example, and right here. So this is all we need, and it also is gonna make a smaller opening in the shield, which you always prefer to have the smallest openings possible in a shield. Otherwise, it's not gonna do its job properly. I'm doing fine, but yeah, .NET. Does anybody in the chat know or use .NET? I know in Germany it seems to be more popular, but in the rest of the world I don't think it is yet, and it's quite interesting. We had a demonstration a few days ago in Belgium by Manuel ON4MOD, if anybody of you heard of him. Oh, maybe we can narrow that down. When you want to hear stuff over RF. Yeah, APRS is very popular about everywhere, I guess. That's in Belgium. It does have a particular statute in the law that the frequency is recognized as a common frequency, and so you can start an APRS relay without having to do all the paperwork that you would need for any other relay. Oh yeah, it's true, DVM does have a .NET gateway. Well, the possibility to have a .NET gateway, I guess. Okay, and the last one Maybe this one. Okay, it doesn't. This can, yeah, I can move that a bit, but not too much, so that we can place vias in between. Like here's perfect. Great. Yeah, it's not because Mario is a plumber that you have to use a plunger, you know? Oh, yeah, like the MMDVM doesn't have a DAPnet transceiver by itself. I mean, it's just a plugin that. So I don't have an MMDVM, so I don't really know how it works. But I guess you have a software that you can add plugins to, and then it would be that DAPnet is a plugin that somebody developed for the MMDVM. Is it? So this can be edited again. Yeah, perfect. Amazing. So we need to get the RF track out of here. And my goal would be to make it go around here or around here. I'm gonna let you have your debate in the comments, and then I'm gonna have a look once you have arrived to an answer, okay? Yeah, there were not enough vias right here, so let's add a few more. Okay. That is plenty of vias, and still we are gonna add a few more soon. Okay, so where would we route the RF track? Let's first... yeah, okay. Let's edit the footprints. And I think I'm gonna need to add a third pad, will I? So let's first, okay, finish the hole in the opening in the bottom. So this, we need to modify it like so. Maybe it's too much. Oh yeah, it's way too much. So that would be, let's try adding 8mm. Okay, we can add 2 or 3 more. I'll remove 2 or 3 more. Okay, perfect. And so how would I need to, okay, I need to make a pad in the bottom and keep that one there. So, oops, sorry. Like this, except that no, let's create let's create, oh yeah, that's one of the things that you can do. You can do lots of weird pads. No, let's try to do a regular pad. Or, yeah, no, we don't need to do a regular pad. I don't know what I'm doing, I'm just trying things. I guess if I remove the right part, yeah, it's gonna complain because then it's not on the it's not on the initial pad. So I would need to okay, let's write down what we are gonna do. It's gonna be useful later on. So this segment we need to transform, to move it in the Y direction. We need to move it by minus 12.05. And then in X, let's move it by 10mm. And so now this, so I said transform X plus 10 and Y minus 12.05. But then we need to move exactly and then do the reverse. So X it would be minus 10 and Y it would be 12.05. And boom, here we go. It stays in the same place. And for that one I can then remove at least this. Also this one needs to be pad number 1, 2. Okay, so Oh, thanks, Steve, for information. I think it's gonna settle the debate in the chat. Okay, what I'm interested in knowing is if we can route this signal yeah, maybe we can just move it this way. It's not really the best way to do, I guess. Maybe I can try different routing technique. Yes. Yes, I could get an MDVM, but I don't know if I would play often with it, actually. At least for now, I'm getting too focused on OpenHT, so don't have time to play with anything else. Okay, and then this... Huh. Okay, no, I'm not gonna get it down this way. I'm gonna get it out by the right hand side, not the bottom, and then go down to the SMA port. So that means that this one it's okay, and this one I need to remove that and shorten this one. Huh. Let's add a segment that's gonna start at 10 and minus 1.35 and end at 10 and minus 2. Oh yeah, and make it 2.5. A bit too much. Nope. Minus 2.5 is what I want to write. Okay. Then this one needs to be shortened 2, so it's gonna end at let's say even 6. Okay, we are gonna route the track first and then see if we need to do any modification after. So go down here. previous tracks. Okay, perfect. It could be a way to test OpenHT indeed. It's true that I have absolutely no way as of now to test if I transmit an M17 signal, except maybe with an RTL which doesn't go up to 2.4 gigs, so I would only be able to test the sub-gigahertz band, but then I could use that and SDR++ to try and decode it. I guess it does have, I think Alexandre told me that it does have an M17 decoder. Yeah, it does. So that would be how I would do it for now, I guess. Yeah, we'll see when it comes to that. But for the FM, I do have a Yaesu to test it, so that would do the trick. Okay, so the thing is, I think I can have loads of vias and repeat a pattern, create a pattern with them. Can I, how much should I need? Yeah, of course I can't measure it, so vertical spacing, I guess I would need at least 15, let's say. Hey! Oh no, I guess thanks for the offer, Bastien. I will tell you if I need anything. But for now, we do have to finish the board, then write loads of code, I guess. And then if we manage to get something working, so the goal for now is to have OpenHT working in analog FM for Friedrichshafen. If we can manage to do that, we will be happy. If we can have more, of course it would be better, but I guess having it working in analog FM would be a great start. Okay, let's 1 millimeter and yeah, great. Okay. Your boss is impressed? Steve, okay. Well, glad to be useful, I guess. This is a nice via shield. And of course we need to add more vias next to the port. I don't remember how it looks like in 3D. Let's view it. Yeah, okay, so we can clearly place them just outside the pad. So right here. Let's keep regular spacing. Oh, you know what? Let's pick metric grid. Okay, now we still have plenty of vias to add. So let's add a few. No, this needs to move a bit so that we can place vias here. Okay, let's try something too. I don't know how it's gonna turn out. Okay, no, first I think, so this is great, this is finished. I need to adjust this. Okay, like this, great. And yeah, these need to go through the bottom layer. Okay, layer, bottom copper, and one and two. Okay. Let's take a few seconds to admire the board in the 3D viewer. So what we need to do still is TVS diode and battery connector. Those two we need to do. And then place vias all around the board, and then the silkscreen, and then that will be pretty much it, I think. Okay, TVS diode. It's time to choose the components. Let's use DigiKey as our search engine. Let's put it in English so everybody understands. Okay, I don't search for these kind of devices very often, so I'm actually not very sure of what I should be looking for. It's nice to have a boss which is interested in ham radio. Yeah, mine pushed me to have my license and start the whole ham radio stuff, and then it kind of got out of control, so yeah. Okay, let's see what the most commons are. I think we will need one with at least 3 pins to protect so one like this, for example. What are its characteristics? Clamp TVS. Yeah, okay. I actually should have been a bit more prepared before looking at this in a stream. Okay, let's try selecting that. And how can this be bidirectional? Oh yeah, maybe actually it's... Yeah, actually it should, I guess it should be, yes. Okay, they don't have kind of an internal diagram, which is very helpful when you want to show how it works. 14 volts is, I think, a bit high. Yeah, this is what it looks like. I believe we should select one with a low voltage, like this one, for example, is 3 volts continuous, I guess. Okay, designed to protect one signal line from the damage caused by ESD and other transients. USB data lines. That's not exactly what we are trying to protect, but doesn't matter. Yeah, low capacitance is important, of course, otherwise we are gonna degrade the impedance of our line. But indeed, this looks nice. Okay, let's have a look at, for example, this one, which does have a higher VC, so 14 volts, and let's see what they claim it's used for. Cellular phone, digital camera, MP3 player, blah blah blah. Okay, they don't have any diagram showing. So this one, for example, 7.2 volts. It does have a weird characteristics. 5V, is it like the... I try to make sense of what I'm reading. Reverse standoff voltage, so 5 volts, okay. Clamping voltage, 7.2 volts. So I guess the reverse standoff voltage is the voltage at which you can... sorry, it's reverse standoff voltage is the voltage at which you can use it, I guess, and clamping voltage is the maximum voltage that it would reach, or no, it would be breakdown voltage. Clamping, I don't do diodes enough. Kind of getting lost in this. Okay, let's use internet to help us. Analog devices and Texas Instrument. They would surely know what they are talking about. Reverse standoff voltage, maximum voltage, maximum working peak voltage. Yeah, okay, so this is indeed the voltage at which we can kind of use it. Then we have the reverse breakdown voltage. Yeah, so indeed, as in a diode, breakdown is when you reverse polarize a diode and then it starts conducting. So yeah, that's what they are saying indeed, also known as the breakdown voltage. This is the voltage threshold at which the TVS diode begins to conduct a specified amount of current. Voltage breakdown should not exceed the absolute maximum rating for the IC it is protecting. Yeah, and I have no idea what the absolute maximum rating of the IC is, but I would guess it's between 4 and 6, something like that. We will have to have a look. Clamping voltage. The over voltage transient is clipped to the level defined by VCL, which is the maximum voltage level seen across the protected circuit. Yeah, oh yeah, this, oh, I like this diagram. Okay, let's... Yeah, that's the typical IV curve of a diode, except that when you do protection diode or Zener or something like that, and these I guess are made out of Zener, you want this, the left part of it, to be very well defined and know which voltages we are talking about. So clamping voltage and breakdown voltage. So breakdown is indeed when it starts conducting, and then clamping voltage, it's like the very maximum bit, the maximum of the peak. And so we want indeed VCL to be at or below the maximum, absolute maximum rating of the transceiver. Otherwise, we are gonna increase. So when the current, the ESD is getting discharged, the current, maximum current, I don't know what it is. It's defined in the standards and blah blah blah. Let's not care about that now. So we are gonna have the current going through the diode, and then of course the voltage across the diode is gonna increase up to VCL, and if it's above the absolute maximum rating of the transceiver, then it's gonna break the transceiver. So task 1, 8086 RF215. Let's have a look at the data sheet and see what the absolute maximum rating is. That's not helping me very much. It surely is not 2 volt, I guess. Analog pins. Well, is it? Huh. So VDD can go to 3.6. In our case, it's gonna be 3.3. Okay, I'm really not sure of... Well, maybe we can compute that actually. Trying to get some inspiration by reading the data sheet. I don't know if it's gonna be any useful. Okay, I'm silly. The device we are trying to protect is not in the end the transceiver, but it is the RF switch. So let's have a look at that one. Supply voltage absolute maximum rating 5 volts. So that means that the TVS should have a clamping voltage at or below 5 volts. And of course, you always try to be a bit lower just in case. Yeah, and you have the ESD human body model, which is 2000 volts. I don't know where I read that, but so when you have static electricity in your body, it can go up way more than 2000 volts. It can go to up to 10,000, I think. And so when you touch your car or any metallic surface and you feel the electricity going through and you hear noise, it's usually way more than 2,000 to 3,000 volts. At this kind of voltages, you often don't feel it and don't hear it. So, yeah, if all the devices that we had were not even protected the slightest for ESDs, then we would kill lots of them very often, I guess, because it often exceeds that and we don't even realize it. So, okay, anyway, I have an idea of what I should be looking for now. So, TVS diodes, clamping max. Let's select that. Oh, that's not a lot. That's really not a lot at all. Hey, what? Why? There is something I don't get. Clamping voltage is supposed to be higher than the breakdown voltage, but this is the opposite. Let's see what's TI. says. They say the same thing. Oh, Okay, would we need a unidirectional or bidirectional diode? I think because of the DC blocking capacitor that we have, not here, here, so we have this DC blocking capacitor, so we expect that the output signal to at least be centered around 0. So that means that the output signal is gonna go below 0 volts, so we would need a bidirectional IV curve. Thanks, Pierre. Have a nice walk, and say hello to the dogs for me. I like dogs. Give them a pat. Let's say. Okay. Yeah. Still don't understand. How is it that the clamping voltage is lower than the breakdown voltage? Okay, let's keep asking Google. Oh, Altium. They do have some nice knowledge base. trying to read it to understand. So yeah, they are explaining the layout and so on. So yeah, that's very logical. Okay, it doesn't help me very much. Yeah, okay, they are saying that if you have an ESD event, the TVS is gonna lower the peak voltage, and as long as it's below the ESD maximum ESD voltage of the device, then it should be okay. So I think that we are gonna select a reverse standoff, so it should be at least 3.3 and let's say at most 4.5. Also, I don't want to have whole reels of them, so can I select, yeah, cut tape or bulk, anything. So what would that be? Peak power of 150 watts. Wow. Impressive. Working voltage 3.3 volts. This is an 0402 voltage. K, sorry. I think this one seems nice. Let's have a look at other diodes, see if maybe one would fit better. This one, what does it say? Okay, it seems to be the same, kind of the same voltages. Okay, freezing. Except that the pulse power is lower, but it's not very a big deal. I think I'm gonna use this one. It seems nice. Clamping voltage is 10.4 volts. I think it should be... Well, we'll see. If somebody kills its prototype by touching the SMA port, that means that this was not enough. I don't think that we are gonna find any device with much lower voltages. Oh, but we need to pay attention to the capacitance. 80 picofarad and 25. Ah, yeah, I didn't think of that. Let's have a look and sort it by... can we do that? Sort it by the... capacitance at frequency. Yeah, we should really use one with very low capacitance. Oh, those two seems nice. Yeah, but it's marketplace stock and we have to buy them by the thousands. Not very interesting. Ah, this one. Loads of stock, not too expensive. Oh, it's very, very small. It's an 0201 package, which is very, very small. I like to avoid that. Okay, let's have a look at these. Okay, let's open a bunch and have a look. Okay, so these seems to be used for very high speed signals. Okay, so this is interesting. Okay, they show that it doesn't alter the eye diagram too much. Great. Okay, this one seems great. Let's have a look at the rest of them. Maybe. Okay, TLP parameter, what is this node 2? Dynamic resistance, okay, if you want. So it is bidirectional. Okay. Yeah, it does protect against 16 kilovolt discharge, which is very high. Aha! There we have it. The diagram that I was expecting, because the breakdown voltage is higher than the clamping voltage, because if you try to idealize the behavior of your diodes too much, then it doesn't make sense. Haha! Okay, I kind of like that one. Maybe also because they have a very nice diagram in it that shows what to expect from a real diode, not only from an ideal one. This one... but... Oh, what is the package of that one? Whew. That's tiny. That's very small. very, very small. Let's try to find a large one. Which package is this one? 0402, okay. Some hope. Yeah, it's lower SD protection. So which package was that one? Let's see. Okay, let's remove that one. And this one doesn't charge. So this one, CST2 or SUD882. I have no idea what it is. Let's prepare that one. That one is too small. And this one is SL2. Yeah, SL2 is the same as this one. It's too small, I guess. Aha. 1 millimeter by 0.6 millimeter. I guess it's closer to a 0402 package. Oh, very high protection. 20 kV. Okay, it would attenuate the signal at 2.4 gigahertz by, yeah, about 0.1, 0.15 decibels, so which is not too much, so it's okay. We could accept that. So this one is very, very small too. This one, it's, what package is it? Yeah, it's also very small. This one. Oh, this one would be. Would be correct package, I think. Yeah, that was one that we were looking at. Oh yeah, that was, yeah, okay, 80 picofarad, so it's way too much. 25. Okay, so SL2, it's too small. 0402, it's great. This 0402 metric, so this is even smaller than 0201. This is ridiculously small. We can't have that in this project. It's just a particle of dust. It's impressive how small you can make them though. Yeah, okay, so it's 0.5 millimeters long by 0.24 millimeters wide. This is just too small. Okay. CT2. So it would be that one. Or this one. What did it look like? 2.9 picofarad. I forgot what that one was. And this one, 15. Okay, it's way too much. So, do they have? Yeah, okay. They don't have any S11 diagram. So let's just consider that if they don't give an S11 diagram, then maybe it's not really made for high-speed signals. So this one is volume dropped. Okay, volume's back. I still have no idea what's happening with the volume. I had a look in the events viewer of Windows and I think I saw nothing. I'm at a loss completely, and it's annoying. Oh, it is. Yeah, a bit more than. Okay, it's. I don't. Oh, this one is too small. Okay, let's. I opened a loads of them. This one not good. What was this one? Oh yeah, no, way too much. Okay, so I guess in the end we are gonna have to choose between the Texas Instrument one and the Toshiba one, and I think I'm gonna pick the Toshiba because it does have higher VSD, which is the maximum voltage that it can take, and I think it's generally better, is it? Did Texas Instrument has an ESD rating to their ESD protection diode? Yeah, okay. Let's use the Toshiba one. I like that one. Okay, so schematic editor. RF. Let's add TVS. I guess they do have diode. Whoa, what's that? DTVS, yeah, that's the one. Huh. Let's just check that KiCad doesn't have that one. Yeah, no, they don't. Okay. So Okay, and what was the footprint that they say they used? It is oh yeah, 62, which is, I guess, not a standard one. Let's have a look at the footprints. It would be in the diodes SMD section. Yeah, you don't see anything. Oh, this is small. Okay, so as usual, let's create one. No, not that one. Okay, oh sorry, I forgot to npn. Okay, command datasheet, let's copy paste. Do we need that? Huh, that's weird. Okay, well, anyway, datasheet, that's this one. Okay, we need to connect it to the ground, connect it to the line we try to protect. Let's let it close. Align those two. Okay. We can even okay. Okay, there we go. So now creating the footprint. Okay, let's close those. We don't need them for now. And footprint editor. Hey Jay, how are you? What was the name of the footprint? 62, okay. 62. Okay. So it would be one pad, second pad. So I guess it doesn't have any polarity whatsoever. Yeah, okay. Oh, yeah, they do have a pin 1 marking. Then we will do that too. This needs to be size 0.9 and 0.35. Oh no, 0.6, yeah. Okay. And so exposition is that, and it's that, except that we also need to set the y to 0. very small. Okay, let's draw silkscreen. Okay, and oh no, I guess this will be good enough. Will it? Let's see. What do the other diodes look like? They add this kind of... Let's steal it from KiCad. I don't want to redraw all this. Whoa. That's huge. Maybe I shouldn't have stolen it. Anyway, then maybe I don't need to draw it anyway. The courtyard. Okay, I just... How wide is the diode? It's 0.6. Okay. Yeah, so let's make that a bit smaller. And let's create a rectangle around that one. Okay. Yeah, I'm satisfied with that. So let's go back to the schematic and select the footprint. Okay, great. It's 10:30 p.m. already, which means that I won't be much longer. Yeah, that's more than 2 hours of stream already. I didn't even take a break. Okay, let's make a short break actually. I want to have some tea, so let's be back in about 5 minutes, guys. See you. Okay, I'm back. So one of the last thing that I would like to have a look at while we are streaming is battery connector. I'm not really sure of what I will be doing, but at least in my mind it makes sense, so let's do that. Maybe we can start looking at Mouser if they have some of what we are looking for. So that would be something like that we would be looking for. So let's just open it and go. Okay, it's in battery blocks. Yeah, sorry, this is in French. I will keep it in French. Website is too slow. Oh, okay. It doesn't have lots of choice. Okay, of course they don't ship that to Belgium because they are annoying. Anyway, we would be looking for something like this, and I guess they will have I hope they specify the connector of that they fit. So as you can oh, it's 2 wires only, huh? Surprising. Or maybe this is not a good picture. Volume. No. Get out. Okay. Back. Yes, we will be looking for 2 cells battery. While we do not need the voltage from 2 cells now, we will later on. And so I designed the power supply stage to have 7.4 volts input. Okay, JST connector VHR N2. It is 2 wires connector. Why don't... Okay, so usually when you have a 2 cells battery, you have 3 terminals, because when you charge the battery, you want to equilibrate it. So you will, at the end of the charge cycle, you will be sure that the 8.4 volt is divided in 2 across the 2 series of batteries. So it should be 4.2 per battery. And so the only way that you can do that when you have 2 in series is if you have a 3rd wire that goes in between the 2 cells. So, okay. But I guess it's gonna be a JST connector anyway. But 3 terminal one. Oh, 3rd terminal on the anytone is temperature not balance. Oh, is it? Okay. Well, this is possible too, I guess. You don't have to, but yeah, okay. Yes, indeed, maybe not a big issue. How should we do that? I'm hesitating. There are two ways to do that. Either we fit yeah, I would like to find a standard 2 cells battery that so okay, let's of course Amazon is gonna pop, but we will have a look, and then it's mainly for RC hobbyists. 2 cells for double voltage, so it's in series. Do you want to use an 18th? It would be... Hey, actually, using an 18650, I don't know how you call it in English, using an 18650 holder would solve one of the problems that I would have, is that I was planning on yeah, of course those have very large connectors because it's for RC models, and it can pump up to tens of amps sometimes, which is not our case here. So so yeah, something like this, for example, you see that there is a 3-pin connector, and it's usually for balance. 18650, yeah, okay, that would be yeah, you're right, Steve, that's what we would be looking at. Okay, let me think a bit. Using a battery holder would make it much easier for us, because then we would be able to charge the battery one by one, which is very easy to do, and an 18650 charger is common and cheap, while charging a 2 cells battery is not easy. You need charging a 2 cells battery in one pack. You need a specific charger with the correct connector, or you need to fit a specific connector, and then we are gonna have batteries with 2 pins, some with 3 contacts, and then it's a mess. So I would say 2 cells lithium battery holder is the way to go, at least for the proof of concept, for now. Later on, we might want to change that. However, we also need a lithium battery holder which puts the batteries in series and not in parallel, and I don't know if we can find that easily. Let's try finding that. If you charge the 1860 cells outside of the radio, each cell is charged separately, so you don't have the balance problem at all. Yeah, most holders don't have connectors. Yeah, it's just bare wires. And then we would need to decide if we want to crimp something, or if we just want to solder that to the board. Or maybe we could even have I don't know how you call that in English. Yeah, something like that, but smaller. And then you could just clamp the wires on the board. I think I would prefer that solution actually. Terminal strip, thanks, Steve. Okay. Let's DIN terminal, but the terminal strip. Screw terminal. That's the one I was looking for. I think it's common. At least I think. I think it would be in here. DIN terminal, mini screw terminal, terminal strip. Okay, there are several ways to call them, it seems. Battery cell size 18650. Number of cells 2. Oh, is it? Oh, that's okay, that's nice. Terminal the screw. Yes, my Franglish is very good. Yeah, it seems very 100% brand new and high quality. Yeah, the battery pack will be separate. We won't place any on the board, that's for sure. And when we will be debugging, we will be powering it via USB, I think. So yeah. It's annoying that I have no idea if it's a series or parallel connection. And they don't specify that, I guess. I especially like the high quality, and you see that it's all very weird. What's this link on Amazon? Yes, that would be yeah, what we are looking at for. Off and no. This one has no switch. It's not an off and no, it's just no. Yeah, okay, joke apart. I'm thinking forward. I want to see that pic of the off and no switch. But yeah, when we will be in Germany, for example, showing the device around, and I expect that we will show them around quite a bit. I don't want the battery to fall off the casing, so I have no idea how protected and how practical it is. Reverse current protection with bare wires. What do you mean? We already have a reverse polarity protection, so that's placed on the board already. I did that a few days ago. It's where is it? Yeah, it's that one. That's the PMOSFET that's protecting it. Yeah, no key. Yeah, of course. If it's bare wire, we have no keys or anything like that. Okay. Let's keep looking on Amazon because yeah, we are on Amazon, but I mean, people will be able to take whatever they want. I just want to have a look at if there are any holders with oh yeah, but this one would be, yeah, it's two in parallel, I guess. Do we have a way to specify the size of the battery that we want? Of course no, because it's Amazon and the search engine on Amazon is shit. Oh, 12 pieces. Yeah, that's something that you can solder on the board, but we won't. Yeah, this is... looks suspiciously like the one that we were looking at previously. Yeah, it looks like this is going to output 7.4 volts. Huh? Can be assembled by different size of battery box, can get the voltage 3.7, 7.4, 11.1 and 14.8. Well, surely not with that one. Yes, we could 3D model the holder and the back case. That would be a duty for you, I guess. Ah, magics. I like my magics. Anyway, okay. So, bare wire it is. I just want to have a look then at the wired board. That's, yeah. I just want to have a look at the pitch, the most common pitch. Oh. Yeah, it seems that 3.5 is the most common one without being too large. No, what, huh. Oh, it's a cute 45 degrees terminal block. 7mm thick boy. You can power the proof concept with a mere 230 volts, 10 amps. You can do EME. Okay, anyway. 3.5 volt, 3.5mm terminal block it will be. So that means that this needs to change, and let's have a look at the schematic. The battery connector, it's in the power supply. Here, footprint, blah 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 blah. Connector, where would it be? A wire, maybe? No, solder wire, it's not that. Huh. So which one was it already? It's J201. J201. Here we are. Okay. Connector tin. No, it's not that one. I'm pretty sure they have. Yeah, that's kind of what we are looking for. Not really. Nope. Terminal block, yes, that's it. Except that they don't have the pitch that we are looking for. Okay, I think I'm not gonna bother too much. Well, those names are long. Yeah, it's all the same, it seems. That one will do the trick. Save. Save the board. PCB. Import the changes. Multiple footprints found for J402. Huh? Oh no! What the fuck? Oh shit! I know what happens. Aha, okay. Yes, of course. J504. So J504. Okay, is that when I placed this shield, I just copied this footprint and then it placed another one for J402, which doesn't make sense. So I then need to remove that. Come on. Why is it complaining? Begone shield. Okay. Wheels aren't saved yet. As you can see, I had to remove them to make them fit in between the shields. We are gonna have a look later on at if we can do something to save them. Or would this be preferable? Okay, in this case it is especially important to add vias around the diode, because it does need a very good ground coupling to do its job correctly. I think I'm gonna keep it like this. So let's call it a day for the TVS. Let's just check. Ah, yes, okay. So I need to update this shield so that it's the correct one. So it would be, okay, let me have a look. This one. And so now, ah, yes, doesn't move. Except that, huh. Weird enough, I didn't have, so I don't know if you remember that I had a problem with the ground pads under a shield. I had the same problem here, but it seems that here, there's not this problem. So, well, okay. Oh, this is useless. Oh, I didn't route that. Okay. TVS is done. This one. I guess I may need to with this. Let's push that away. Okay, I will need to move that away so that I can have. Okay, this like that, more like it, and let's use a huge track. This is the main power supply after all. Okay. Well, if I'm right, we have all the components we need on the board. And the only thing that is left to be done is some more vias connected to the shields below, vias and tracks, just like I did for this one, doing the same thing for those 1 and 2. That I think I will do off camera because it's not very interesting. Then trying to add a via stitching that I think I will also try to do off camera. You saw me place way enough vias for me to send you more of that. Oh yes, good idea, Jay. I'm gonna try to fit the shield. Let me go ahead and download the files you gave me. Okay, let's close all those tabs. Okay. Okay, don't need this and don't need. Oh, okay. Okay, so it's all the same names. So I just need now to add this one. Woo! It actually seems perfect. And it's actually square, so yeah, okay. No need to yeah, okay. Yeah, no, good. It does fit and it seems to be centered around the footprint, so no worries. I guess you made it so that it's flush on the surface. Okay, great. Thank you very much, Jay. It's very nice. Very impressive too. So that means that it's not displaying yet because I believe I need to general update footprint. Woo! Nice. And we can see that, yeah, we shouldn't use inductors which are too high, otherwise it's not gonna fit. But that we already knew. Great. I'm trying to imagine what it's gonna look like with the two other shields. It's gonna be amazing. Okay, I should also add a key on the silkscreen of the TVS to show which pin is the number 1 and which pin is number 2. So let's do that now. You know what? Okay. So I didn't save the board while I was working on it. I didn't see the point. Oh, that's. Okay. So as I said, I didn't update the board on the GitHub because I was working on it and so on it. So yeah, but I'm gonna I may have lost. Oh no, it's okay. M17 logo. Where should we place it? I think somewhere around here. Doesn't have, yeah. I think here is the best location for it. There is nothing going around, so it's not gonna be messed with because of vias. Okay, I was thinking about something. I forgot what I was thinking about. Yeah, okay. This, I want to do that before I forget about it. And open source logo. Yes, why not? But that's, yeah, Voyager, just tell me what logos you want me to add or not, and I will do it. Not today though. Okay, I'm gonna add a small designed in Belgium label. I'm also gonna add a few features to see the layers of the board, so that when you see the board, you see that it's a four layers board, and also it helps the manufacturer understanding what it should look like. So it can help him correct our mistakes if we did any during the export of the files. Yeah, my call, version, the dates, things like that, it's things that I add to a board once I'm finished with it. So don't worry, it's in the end of the cosmetic stage of the design, and we didn't start the cosmetic stage yet, so no worries at all about that. I wanted to have a look. Also, what's the price of these? Okay. It's surprising, Mauser is always a tiny bit more expensive than the G key. I didn't know that. Yeah, it would be cool to certify it for the open source hardware. But I don't know what we need to certify it and so on. If you want me to place a logo on the board, I will do it. But we shouldn't lose too much time trying to get a certification before producing the board. It's also just a proof of concept for now. As I said, for Joe, but as I said, yeah, it might be a board with lots of bugs that you will have to patch by hand and so on. So it's really the V0.1. The goal of the Wiggers is to be in the PCB on the signals, the fast signals. So if I can add them there, I will. Okay. I'm losing. Yeah, okay. Why did I wanted to add a key, but I don't need to add a key because I have this thing, so it's good. Anyway, it's a TVS. There is no polarity to it, so we don't worry. Okay. Let's re-export the schematic because it changed. Okay, done. Re-export the step file. And let's have a nice 3D view of the board. Yes, you're right. The logo is upside down because the board. Yeah, the board is gonna be. It's the board that's upside down actually, because I designed the whole thing with the SMA connector at the bottom. But would it be easy to? Ah, yes, those are locked. No, I'm not gonna flip the board now because I don't want to get confused. I know the board as it's now, so. But yeah, we can have a 3D view just like this. It's the tie down in Australia. No, of course it's not in Australia. That's the magic of Australia. Let me. No, okay, it's good. This way. Then, yeah, maybe I will still want to. Do that. Oh, it would be upside down in Austria. Austria is on the good side of Earth, of course. Whatever good side of Earth mean. I don't like the logo here. I'm gonna place it here for the sake of the picture. Yeah, okay. M17 sur la droite. Yes, we are gonna need more shield step files. If you agree to do the step file for these, only one of course for the two shields because it's the same shield, it would be amazing. And also one of the step file that is missing is the one for this coil. It would be very nice if we could have that one too. So yeah, because for the QFNs, as I said previously, I do believe that there is a way to generate them automatically. We do have a step file missing here and there, but it's not very important. Well, those would be cubes anyway. But the QFNs, I think I can get a script to generate them automatically with the colors and the pins and so on, so it would be nice, very nice representation, and I will try to have that if possible. So yeah, and so if you need the reference for those shields, it's let me no, it's not that one. This is the MS338-10F, and this is okay. Okay, so there is a mistake in the schematic. Okay, I'm just gonna go back here and... Oh, yeah, okay, I did that, so let's do that here too. Value and the FPGA value, that's the same. So the reference for the new shield is MS300-10F, if you need it. Yes, bedtime for me too, so thank you, Wojciech, and see you tomorrow. So I don't know if I will be doing a stream tomorrow, or maybe just off stream doing some small things. Friday, I think I will have some time available too, so just before the weekend, and we will see. Okay, schematic, we export that because I did some changes. Close. And it's good. Git. Okay. Oh yeah, I updated the... I think you would be good with a parametric model, I believe. Also, we don't really need it to be very precise, so if parametric model is a bit off, I don't mind. What is mostly important is let's say the bounding box of the shield. That is important, because if later on we want to reuse them and try to do some checks in a more complex 3D design, then we want the bounding box to be okay, but for the curvatures and so on, we don't really care. Okay. Did that change anything? Trying to keep the Git history quite clean, so trying to avoid pushing everything when it's unrelated. Well, this is gonna have loads of dates. Okay. So with this last commit that I did, I think you should be able to see the board with all its step models and so on. Oh no! I think I messed up right here. Now that I'm thinking about it. Yes, it's no good. That's better. Okay. Ah, here. Come on. Okay, I can, with Git Kraken, you can easily cheat a bit, and so I could do, if I, okay, why don't I? That we don't need. Hey, I should be seeing. Ah. Okay, that's why. Okay. This and that. Like this. Yeah, the part where you commit all your changes is not always the most fascinating. This is not gonna do it. Okay, okay, good enough. So I think I went through all the sheets that I needed to go through, did I? No, not exactly. So those are all BOM updates, or bill of material updates. And I'm gonna push the oh no, I think this needs to go. There are two. Nope. Okay. Okay. And finally, okay, and push. Okay, it's getting late. I'm getting tired. So thank you all for following me today. It was nice having you. I like when we have few people to interact with. It's always funnier than when I'm alone facing my screen. So yeah, thank you everybody. Take care, 73s, and see you on the next stream. Bye bye. It's never gonna stop, is it?